Hi everyone. In our last episode, we had shown you the transformer action taking AC current and DC current into consideration. And while showing that, you might remember while using AC current in a transformer action, that means in a coil which will be input, then transformer action was perfect. We had shown you, remember, with this setup. This is the input setup, a coil, the two terminals coming out. Using these two terminals, we have to provide AC current, which we have already shown. If we provide, suppose 12 volt AC here, and this is the output coil, and if you contact both core together, we have already shown you in the last episode, this LED was glowing perfectly. Now we had a problem in explaining that DC current never induces. That means transformer action cannot be shown using DC current. While showing that, you might remember we had used this rectifier. And I have already told you that this rectifier has got 4 pins, 2 input going to the transformer. Suppose you are using 9 volt, then 9 volt AC is inputted. And then these two are the output terminals. And those output terminals we had used in this setup. And today I will repeat that. And we expected that this induction would not happen. But dismaying us, there was induction. And I told a story. You might remember the story was like that. This rectifier produces pulsating DC but not pure DC. And to rectify that situation, I promised to show you in the next episode using a battery which is a perfect DC source. Induction will never take place. That I want to show you first using this battery which is having 9 volt. You might see there is a plus and there is a minus. And this 9 volt battery is an alkaline battery, so it has got very high efficiency. And using these two terminals, connecting these two terminals, I will show you induction will take place for a moment but not permanently. Please take a note. It's very important now. This coil setup is already here on this. And my duty is to connect these 2 points to these 2 terminals. Let me connect. And you have to please carefully watch this LED. I think for a moment only, the moment I connect or the moment I disconnect, this will be only glowing. Please take a note of that. So this is while connecting, no response, but while disconnecting, this LED responds. But if I make a contact, it won't glow. But the current is flowing through the main coil. But there is no transformer action, that means no induction in this coil. Again, I have to repeat so. What is that important? I have already told you for a DC source, if you connect, then there will be an induction. If you disconnect, there will be the induction. Let me check again. If I connect, what happens? If I connect, not possible. If I disconnect, it glows. When I reverse, you will see when connecting, it will glow, and when disconnecting may not. So anyway, I reverse, and this is for final confirmation that at a point only there will be induction, not always. This is as many times we do, this effect will continue. But now, please be serious. In our last episode, we showed you using a pulsating DC, we could not check induction. Now these 2 points are our positive and negative points. I will show you using my multimeter. I keep my multimeter pointer in DC voltage measurement range because we have already told you this is a pulsating direct current. Now how I measure? Please check. I do have one positive, one negative terminal. So also here I keep negative and I attach positive. And please observe that the voltage is almost 9 volt. This is something 9.4 I have noticed. So that was the idea. Now I may repeat the measurement. Please check. One point and the other point is 9.2 something. Now as far as this battery is concerned, I will also show you the same result we have selected. This is 8 point something 8. So this is almost 9 and getting down gradually. So forget 9 and 9. So this is pure DC and this is pulsating DC. What we said by term, I again measure and please check. This is 9.3. So this lamp is glowing using 9.3 as the source. And now making the multimeter off. Today we are very happy to introduce a new device before all of you, which is a high-end cutting-edge device mostly used in electrical labs and college level setups. So what is that? Please observe this setup. This is called oscilloscope. This is such a nice device. This will be giving you a new insight into the graphics of alternating current, pulsating DC current and direct current. So we have 3 sources now. I show you where to get AC current. These 2 I will request. I think these 2 will be perfect AC. I will connect here these 2 probes. Pulsating DC I will be connecting here and here, and pure DC across these terminals. So please be sincere to follow the graphics, yani the graph culture, the graph curves of pure DC now. So please observe, when I put my probes on these terminals, you will find the blue line goes a little up, showing the voltage of the DC source. Now if I disconnect, you will find that blue line will come to the axis line, that means 0 line. Touching, it goes high but straight. Disconnecting, comes to the reference point, that means the 0 level, and this is in the language of physics is a pure DC curve. That means it is a straight line. It's a voltage and the current remains constant across. So one part is over. Now coming to the alternating current, please observe carefully. The graph of 9-volt oscillating current or alternating current. It is such a current, the graph, part of the curve is above x-axis and part of the curve is simultaneously below the x-axis. That is why this is called alternating current. That means goes up, comes down, goes up, comes down. So this is the variation, and that is responsible for a variety of magnetic field. That means a varying magnetic field, which we call in the language of physics a changing magnetic field. And we have already explained, for induction to take place you need a changing magnetic field, not a constant magnetic field like this battery. It has got a constant magnetic field, so it won't happen in induction, it will not take place. This is the source of direct current. Now we are very happy to again inform you that why induction we could not prevent in case of pulsating DC last time. You could check now. Although this is DC, that means the curve never goes below the zero line. But above the zero line, if you check, there are hills. That means current is never constant. It increases, then comes to zero, then increases, then comes to zero. Like that, this continues. So this is also a variation and responsible for induction in a transformer action. So friends, we are very happy to introduce this high-end device in our today's episode. I hope we all have enjoyed this, because this is something eye-opener. Because in our books we just see these graphs, but we never experienced by our eye. And today we experienced. So thank you all, and hope there will be various queries for this demonstration, and we'll be very happy to answer your queries. If you see, we'll be happy. If you don't see, then how could we be happy? So it is our sincere request to start the video and to end it also. Otherwise you can't find the details. So thank you. Again, meet in the next episode.